Yes, please go ahead.
Okay, all right. Hello, everybody. I'm just happy to be here to talking to whoever is there. I don't know who is in the audience, but I want to make some comments about my favorite type of my whole life is the star formation processes, and and a related question is the minimum mass of a star. The star formation processes are, of course, complicated processes, and it's a long story. I looked into I started with when I started working on low mass stars, I was basically at that time, I was looking for at that time, nothing much was known. In 1958, nothing much was known about low mass stars, observationally or theoretically. So I started, I said, well, if I'm going to find the lower masses, stellar masses, then I better start with the beginning. So I started computing models for the collapsing stars around 0.15 solar mass, and then it was clear that that object will become a main sequence star, hydrogen burning stars. And then I went to lower masses, then the interesting things started happening. At 0.1 or below that, I could see that the evolution or the formation process or the collapse process will make the object partially degenerate. And that was the beginning of the 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 domain, the part of the stellar domain, which deals with the stars which do not burn hydrogen. They do not have hydrogen burning process inside their interiors. So I established the hydrogen burning limit, and which came out to be about 0.9, between 7 to 9% solar mass. And of course, all of you know about that. That's an old history. Now, the problem is, at the same time, although I solved one problem, another problem arose, not because I wanted to be part of it, but some people saying, well, you have established the minimum mass of a main sequence star, hydrogen burning star. So that is the limit of the lower limit of the stars. I said no, because while I was in my papers, I said clearly the stars with mass below the hydrogen burning limit will keep on collapsing, keep on shining, keep on evolving, and eventually they will become completely degenerate stars. So I kept saying that, but people say, oh, you are talking about planets. This is 1960s. Well, so the whole thing started, this fight or argument started in the 1960s, and unfortunately is still going on, because I see papers being published in 1925 calling these objects, of course, the commonly accepted term is brown dwarf, which is fine, but now they're at the same time, they're talking of sub-brown dwarfs and free-floating planets and planetary mass objects. This is all unnecessary. They're all stars, and we have already decided that they should be called brown dwarf. So it doesn't matter what the mass is. If the object was formed by the star formation processes as the stars above the hydrogen burning limit did, then they are the stars. So what is the problem? Well, the problem is being created because they love to create new names and new terminology. Some astronomers like to do that. Well, but that doesn't change the basic nature of the object. The basic nature of the object is star is a star. Is a star born as a star? It's always a star. It's evolved, it changes, it can live short time, it can live long time, but it's a star. So once we have said the stars below the hydrogen burning limit are are same process. They were formed by the same processes at the above the Hubble limit, and fine, you want to call them brown dwarfs, fine, but don't say they are not stars. So it is fine if you say, when you say brown dwarf stars, I'm very happy. Or if you want to say any other name, which basically built into the name that is a star formed by the usual star formation processes. But people are not doing that. I mean, it's amusing. I mean, these objects now. Jumping to the minimum mass question, the minimum mass, I'm back in the 1960s, and in several papers, there were 3 or 4 papers, I suggested a name. I suggested very clearly that the minimum mass is not, of course, is not 7 or 8 or 9% of the sun, but it's not even, it's even lower than, much lower than this. And I talked about the values between 1% to, 1% of the solar mass to 100% of the solar mass to 1,000. Now, this is all in my paper. These numbers have been mentioned, and jumping to present time, all these times have gone by, and the years have gone by, and I have been thinking about what the minimum mass is, and whatever I can say now, I want to say now, is the minimum mass of a star is close to 1,000 of the mass of the sun. Now, don't be disturbed that this is the mass of Jupiter, because Jupiter is in a different domain. That's a different kind of object. Those are the domain of the planets. Don't get confused with the stellar domain, with the planetary domain. They're 2 different domains, different properties, different formation mechanisms. Star formation mechanisms are very different. They're done by the stars are formed by fragmentation. In the case of the planets, we don't even really know how they are formed and how they evolve, but they are not formed like stars. They are not formed like stars. Okay, so 1,000 of the solar mass for stellar fragments, it doesn't bother me. What the mass is, if that's the minimum mass, that's it. You cannot change its nature by giving it funny names. Free floating planet and substellar objects are planets, are extrasolar planets. I mean, this is all we make up these names. This doesn't change the nature of the stars. So don't forget that. We want to know what's going on out there, not what we wish. We don't want wish. We cannot change the universe by our wishes and by using funny terminologies, unnecessary terminologies. So let me conclude. You have other serious things to discuss. So let me just say finally that yes, I am against all these funny names. Stars are stars, and from the beginning to the end, a star of 1% of the mass of the sun is formed as a star, and it will end as a star of 1% of the solar mass. No matter what you say, deuterium burning or no deuterium burning, lithium burning or no lithium burning, boron burning or no boron burning, it will keep on collapsing. It will become more and more degenerate until it becomes completely degenerate, and of course it will sit there forever. So brown dwarfs are forever. Okay, so this is my final sentence for you, and I'm sure some of you, or all of you, have some questions. So I would prefer not to answer them right here at this time because I have a hearing problem. I want to hear your question clearly, understand it.